Dear viewers, welcome to the YouTube channel H2O Chemistry. So in this video, I'm going to talk about the relationship between the valence electrons and then valency. Now, and I'm going to relate the group number of the periodic table and to the valency part. So it will be very easy for us to identify the valency of the particular element. So if you know the group number, it is very easy for us. Now, to continue with that, just watch the valence electrons video and its importance. So it will be very helpful in order to learn the concepts. So then if you watch the video, it will be very helpful to learn this video as well. Now, let us go to the first one, that is a valency part from the valence electrons. Now, let us write the electronic configuration of few elements so that you can easily learn the concept. Now, let us go to the first one, that is hydrogen. The atomic number is 1, the mass number is 1. So in the K, L, M and N. So in the K shell we have only one electron, so other cells are empty. Next come to the helium part, atomic number 2, mass number 7. In the K shell alone 2, other cells are empty. Third is lithium, sorry, here is 4. Lithium is 7. Here mass number, atomic number is 3, mass number is 7. So the K shell has 2 electrons, 3 electrons we have, so L shell has 1 electron, other 2s are empty. The next is fourth one, it is beryllium, the mass number is 9, 4 atomic number has 4 electrons in it, so 2 in the K shell, 2 in the L shell, right? Fifth one, boron, 11 it is, the 5 electrons we have 2, 3. So this we have already studied in the last video, right? Last few videos, and 6 electrons we have 2, 7. And the seventh one, that is nitrogen, 14 it is, 2, 5. Other 2 shells are empty. Now come to the next one, that is 8th one, oxygen, 16 it is, 2, 6. Others are empty. Next one, 9th one, fluorine, 19, 2, 7. Other 2 shells are empty. Next one, 10th one, neon, 20 it is, 2, 8. The 2 shells are empty. So this we know already, my dear children, right? Next one is sodium, right? 23, K, L, M and N, 2, 8, 1. The next one is magnesium, 24, 2, 8, 2. The last shell is empty. The 13th one is aluminium, 27, 2, 8, 3. And the 14th one is silicon, 28. There are 14 electrons, so 2, 8, 10. The remaining is 4, so 4 electron goes to M shell. 15th one is phosphorus, this is 31, 2, 8, 5, right? The 16th one is sulfur, that is 32, 2, 8, 6. The 17th one is chlorine, 35.5, 2, 8, 7. The last shell is empty. The next one, 18, argon, 2, 8, 8. The 19th one is potassium, 2, 8, 8, 1. So the last shell is filled, right? So next one is calcium, which is 40, mass number is 40. There are 20 electrons, 2, 8, 8, 2. So this is what we have learned so far. Now, what is this relationship between the valency first of all? Now look at this periodic, look at this electronic configuration. So the maximum capacity of K shell is 2. The hydrogen has 1 electron, right? Now the hydrogen has a if hydrogen has gained electron, it will become 2, or else if the hydrogen lost this electron, it will become 0. So in hydrogen case, both it will happen, so either losing or gaining. So the valency of hydrogen is 1, right? So let us write the valency V part here. The valency of hydrogen is 1, right? Come to helium, the K shell capacity is 2, completely filled, so we cannot remove or add electron to this K shell, so the valency part is 0, so it is 0. Now come to the next one, lithium. The outermost shell has 1 electron, which is like hydrogen. The outermost shell has a 1 electron, so the maximum capacity of this shell is 8, so it can gain 7 electrons, or it can lose this 1 electron. Gaining 7 electron is tough process, is not difficult, is a difficult process. So gaining 1 electron is easy, losing 1 electron is easy. So it loses this 1 electron, right? It loses the 1 electron. So after losing this 1 electron, the valency, the electron participate in the reaction is 1, because during the reaction only 1 electron is lost. So because gaining 7 electron is difficult, to make this shell 8, that is a stable electronic configuration. So losing 1 electron is usual for the lithium atom during chemical reaction. The valency is 1. The valency is 1. So let me round it so that it will be easy for you to identify. Come to the beryllium atom. It has 2 electrons, but the maximum capacity of the shell is 8. So it needs to gain 6 electrons. Gaining 6 electrons is tough process by when you compare to the losing 2 electrons. So during chemical reaction, beryllium loses this 2 electron. So the valency is 2 as it is. Now come to the fifth one, boron. It has 3 electrons. It can gain 5 electron to become this to make the shell 8, but gaining 5 electrons, okay, comparatively is difficult. Losing 3 electron is easy process. So losing 3 electron normally happens in the chemical reaction of boron. So the valency part is 3. Now come to this carbon. Carbon, it has already 4 electrons, and it needs to gain 4 electrons. So it can happen in both the way, right? Even it can lose electron or gain electrons. So in both the manner the number is 4. So the valency is 4. Now come to the next one, nitrogen. In the nitrogen, the outer shell has 5 electrons in it. How many electrons? 5 electrons. In order to make the shell 8, right, so it needs 3 electrons, right? It can either lose 5 electrons or gaining 3 electrons. So you could easily see gaining 3 electron is easy process when compared to losing all the 5 electrons. So the valency is 3 here. Understand? Now come to the next one, the oxygen. The valence electron is 6. The last shell consists of 6 electron. In order to become 8, it needs 2 electrons, which is easy process. Losing all the 6 electrons or gaining 2 electrons. Gaining 2 electron is easy, losing 6 is difficult. So the valency is 2 for oxygen. The primary valency is 2. Got it? The next one, fluorine. So fluorine, you can easily see fluorine, the last shell has a 2 electron, last shell has a 7 electrons. So the last shell capacity is 8. So it needs 1 electron to make the shell fulfill, to gain the stable electronic configuration. So this 7 electron losing is difficult. 1 electron gaining is easy process. So the valency of fluorine is 1. Got it? Now neon is 20. Again the shell is fulfilled with 8 electrons. So we can either remove electrons nor add electrons. So the valency is 0. So the valency is 0 here. So that's what you have to understand, my dear children. The valency is 0. Now come to the sodium part again. So here also the valency, okay, the last shell has 1 electron gaining. So the maximum capacity is 8. So the gaining 7 electron is tough process. So only 1 electron it will lose. So the valency is 1 here. Come to the magnesium. Gaining 6 electron is tough process. Losing 2 is easy comparatively. So the valency is 2. Here it needs to become 8, it needs 5 electrons. Gaining 5 electrons is difficult in compared to losing 3 electrons. So the process, the valency of this aluminum is 3. Silicon, it's similar like carbon. You could see either it requires 4 electron or it can lose 4 electrons. So in this case the valency is 4. Come to this phosphorus. Now phosphorus has a 5 electrons in the last shell. The maximum capacity is 8, so it requires 3 electrons. So losing all the 5 electrons is difficult process, but gaining 3 electrons is easy. So this process will not happen. Easily this process will happen. So the valency is 3 here. Got it? Now come to the next one, sulfur. Sulfur has 6 electrons in the last shell. So it can gain 2 electrons. It is easy process when compared to losing 6 electrons. So 2 is the valency for this. Similarly for chlorine, 1 electron gaining is easy when compared to losing 7 electrons. So it is not happens. only one electron will be gained, so the valency is 1. Argon, similarly, the maximum capacity is reached, so the valency is 0. Come to the potassium, the valence shell has 1 electron, so losing 1 electron is easy. L shell, again the first maximum capacity is 8, so gaining 7 electron is tough process, losing 1 is easy, so the valency is 1. Calcium, gaining 6 electron is tough, losing 2 is easy, so the valency is 2. So this is applicable up to 20 elements. So this way of calculating valency we can adopt up to 20 elements only. 20 elements only, so not more than 20 elements, this concept will not work. So up to 20 elements only, the valency of finding this metal will be work. Now what is the beauty of relationship between, I can say, valency and group number of the periodic table? So that is what our next concept. You could easily see here, right? Now we will see the periodic table. This periodic table is clearly visible to you. Now let me show you the valency of the particular elements. Now we will see one by one what is the valency of the particular elements. You could see the valency of hydrogen is 1, right? The valency of lithium is 1. Then the valency of, I'm talking about only the outermost shell electrons. The outermost shell electron is 1, I'm talking about it. The outermost shell of hydrogen is 1. The outermost shell of lithium is 1. The outermost shell of sodium is also 1. You could see here sodium is also 1. The outermost shell of potassium is also 1. Right? So all these elements, hydrogen, lithium, sodium, potassium, all have same number of outermost shell electrons, that means valence electrons. So they belongs to group number 1. Hydrogen, lithium, sodium, potassium, rubidium, cesium, all are having 1 electron in the last shell, so their valency also 1. Their valency also 1. So this is what you have to understand, my dear children. The next one, we will go for the valency, the number of electron present in the last shell. Let us go for this beryllium. Beryllium has a 2 electron in the valence shell, 2 electron in the valence shell. Similarly, magnesium also has a 2 electron in the valence shell. The last element, calcium, also has a 2 electron in the valence shell, right? So all these 2 electrons are nothing but group 2, right? Beryllium, magnesium, calcium, strontium, all having the valency of 2. So if you know the group number and its elements, it's easy to find out the valency. Next is, come to the next one, that is a boron. Boron, it has a 3 electron in the valence shell. Am I right? Similarly, look at the aluminium. Aluminium also has a 3 electron in the valence shell, right? So it is there, you could see as a 13th group. So 13th group, cut this one, you will see 3. So it has a 3 electron in the last shell. So the valency also 3. Valency also 3. Come to the next one, that is carbon. Carbon is 4. The number of electron present in the last shell, valence electron is 4, right? Similarly, silicon also consists of 4 electrons. So they belongs to 14th group. You watch, carbon, silicon belongs to 14th group. So here, how do you find out the valency? Cut this one. The valency is 4. You could see here. Similarly, the next one is nitrogen. It has a 5 electron. You could see here it has a 5 electron, right? Similarly, phosphorus also have a 5 electron in the last shell. So the valence shell has a 5 electrons. So they belongs to, you could see here, nitrogen and phosphorus belongs to 15th group. You cut this one, number is 5. So the valency, now to calculate the valency, when you come to more than 4, that means 5, 6, 7, how do you calculate the valency? We normally do like this: 8 minus the number of valence electrons. So here number of valence electron is 5, so 8 minus 5 is 3. So this group valency is 3. You could see this is what we have got here too. Nitrogen valency also 3, phosphorus valency also 3. Got it? The next one, that is oxygen. We will go for the oxygen case. Oxygen case, the number of valence shell electrons is 6, right? 6. Similarly, sulfur also has valence electron 6. Number of valence electron is 6. So they belongs to the group called 16. You could see here 16: oxygen, sulfur, selenium. So the group number is 16. You cut this one, you could see 6 here. So how do you find out the valency? This is valence electron. How do you find the valency? So 8 minus 6, answer is 2. So that is the valency of this group. Got it? Come to the fluorine, chlorine, this case. So fluorine has a 7 electron in the last shell. Even chlorine has 7 electron in the last shell. 7, 7. Got it? 7, 7 in the last shell. So that's why they are belongs to 17th group. You cut the 1 here, you see 7. So the number of valence electron in the particular element is fluorine, chlorine, bromine, iodine, acetylene. All these case is 7. How do you calculate the valency? 8 minus 7. The valency is 1. The valency is 1. So this is a valency. So if you know the group number, you can easily find out the valency. Now come to the next one. That is a neon case we will go for. Neon, the last shell has 18 electrons. Even the argon, you could see here, argon has 8 electrons, right? So there is a one exception here. Helium has a 2 electrons, but the shell is filled. That is what you have to understand. The K shell is filled. Here also L shell is filled in neon case. The argon case, the M shell is filled. So shell is filled, so they belongs to last group, that is 18th group. You could see here helium, neon, argon. So in this, all these elements except this helium has 8 electrons. That is why the number belongs to 18th group. So if we cut this one, the number of electron in the last shell is 8. Neon, argon, krypton, xenon, radon all have 8 electron in the last shell except this helium, which has only 2 electrons. So how do you find out the valency? 8 minus 8, 0. So the valency is 0. That is why this group is called 0 valency elements, or 0 group we simply call. How do you call? 0 group. So this is how we can easily find out the valency. So now we could see some easy manner we can understand. Look at this. This portion I didn't talk about. We will see little bit later, because we are concerned only about this first 20 elements. So this is 21 onwards it's coming. So not a problem. So we will see only these elements alone now. Look at this. The valency of this group is 1. First group is 1. Valency of second group is 2. The valency of 13th group is 3. 14th group is 4. And then it decreases again. 15th group is 3. 16th group is 2. 17th group is 1. 18th group is 0. So it starts with 1, 2, 3, 4. 3, 2, 1, 0. So there is an order in the valency. So it's very easy for us to learn if you learn it. Now there is one more beauty, my dear children. Now if the number of valence electrons, 1, 2, 3, they all belongs to metal category. So we could see all this side we have metals. We have a metal. So in normally periodic table, all on the left hand side, on this left hand side we have metals. So when the number of valence electrons, the valence electron of the group 1 is 1, group 2 is 2, number of valence electron in the group 13 is 3. So usually the metals have 1, 2, 3 valence electron in the last shell, whereas the non-metal, you could see here, having 4, 5, 6, 7 electron in the last shell. So on the right hand side we have a non-metals. Non-metal usually have 4, 5, 6, 7 electrons in the last shell. It means they have 4, 5, 6, 7 valence electron in the last shell. So they all belongs to non-metals. The last, when any element have 8 electron in the last shell, they belongs to the category called noble gases. They belong to the category called noble gases. They call 0 valency, or otherwise called 0 group. So there is a huge relationship between the group number and the valency of the particular element. I hope this idea is very helpful in learning the valency of the particular element, my dear children, right? So keep learning. It is very important, my dear children. So this will give you immense knowledge to know the idea about the valency and its importance. Okay, let us see some examples how to find out the valency of sulfur. Okay, I just want to know the sulfur valency. So first, what do you do? So you should know the atomic number first. Sulfur, the atomic number is 16. Now how do you write the electronic configuration? 2, 8. So now 10, the last shell has 6 electrons. Now we know that the maximum capacity is 8. right? So it requires either 2 electrons, gains 2 electron or 6 electron. So or losing 6 electron. So which is easy process? Gaining 2 electron is easy, losing 6 is difficult. So the valency is 2. So we can easily calculate this 2. So this is the one method we can easily calculate. Or what is how many number of electron in the last shell? 6. So you minus this 6 from 8. So 8 minus 6. 8 minus 6, 2. That is again the valency. So this is how we can easily calculate the valency. Or else, what is the next one? The group number of sulfur is 16. You cut this one, it says 6. The number of electron present in the last shell. So this is 6 indicates number of electron present in the last shell. So this 6. What is the maximum capacity of last shell? 8. So 8 minus 6, 2. So this is how also we can easily find it from group number. This is number of electron present in the last shell. If you minus it from 8, we get 2. Or else, which is easy process, you can easily say. Gaining 2 is easy or losing 6 is easy. Losing 6 is difficult, gaining 2 is easy. So the valency of sulfur is 2. Got it? So that likewise we can easily find out the valency of the particular element. I hope this video will be very helpful in learning the valency, my dear children. This concept is very, very useful if you learn it for the future too. Thank you so much. If you like this video, subscribe and click the bell button to get the notification instantly. Like this video, share it to your friends, let them learn the chemistry concepts easily and more conceptually. Thank you.